Hello coders, welcome back to Coding Hub, and in this video we'll be basically covering arrays. Now we'll be covering the entire Kotlin collections from arrays, sets, map, array list. So we'll be covering all of this, but if we try to cover all of this in a single video, then the entire length of the video will be much higher, which will basically reduce your engagement. So for this video, which is basically the part 1 of Kotlin collections, we will be basically covering the arrays. Now you will be wondering why there is a concept of array in Kotlin, right? So array is not specific to Kotlin language. Array is present in most of the programming languages. Now let us understand why we actually need an array. Okay, so let us suppose there are hundreds of students in a classroom. Now you want to store their name in Kotlin, right? So let us suppose you want to store all of their 100 names in Kotlin. So by the traditional knowledge which you are basically having, what you will be doing, you will be basically creating 100 variables or var, and you will be assigning each var to their name, right? So each of this variable will be basically a string, right? But the majority, or we can say the major problem over here is that as the number grows, it will be much harder to recall each of these variable names, right? So for this, what we can do is we can basically use the concept of arrays. Okay, so what arrays do? Array basically keep all of this similar thing inside a single name. So let us suppose we want to store student names, right? So we can have an array which will be basically array of student names, and then we can name the array something like student name, and we can access each of the name by using a index. Okay, so let us understand it in a code. So what we can do is we can simply come down over here. We can simply say val, we can say students. Okay, so these students are basically, where we will be basically storing the names, and then we can say array of, and let us pass the names. So we can say something like, Ajay, then we can have Sam, then, we can have Viru, then we can have any other name like XYZ. Now you'll be wondering, okay, so we are now having all of this name, right? So this name, this Ajay, Sam, Viru, XYZ are now part of this students array. Okay, so this is how we basically declare and initialize a string array. Okay, now how do you access each of this name? So you can access each of this name by using, indexing. Okay, so what we can do is we can simply say students, and then we can simply say 0. Now whenever we have a collection, the indexing starts from 0 and it gradually increases as we go from left to right. Okay, so let us suppose you want to access Ajay, then the index will be 0. Let us suppose you want to access Sam, then the index value will be 1, right? So let us, run this particular code, and if we do this, we'll be finding out that we'll be getting this value, which is Ajay, right? Okay, now it will take some time for the Gradle build to run. After this, what we can do is we can, also try to print the remaining values. Okay, so let me rerun this one more time. Okay, so what I will be doing is I will be keeping it as student1, and let me rerun this. Right, so now we can see Ajay for 0 index, and we can see Sam at index 1, right? Similarly, we can do for the remaining things. We can simply say print ln, and then we can say students, and then we can say 2. For 2, we'll be getting this Viru. Okay, so let us rerun this. See, now we were able to achieve this Viru, right? So till now we have known how to basically, declare and initialize an array, and then we have also seen how to access an element. Let us see few more things, and let us jump into all of this one by one. Okay, so for now I will be commenting out this. Okay, now let us focus on the remaining thing. Similarly, like what we have, done till now, we have basically initialized an array of strings, and each of the strings were basically name of the students, right? So similarly, we can basically have array of numbers. So we can say numbers equals, we can say array of, and then we can basically pass any number like 1, 2, 3, 4, 5, okay? And then what we can do is, we can also have another way of doing the same thing. So let us suppose a user want an array, but the thing is that he don't want to, initialize the all values for now. He just want an empty array, or we can say an array with all the elements 0, and he will be initializing the value, sometime later. So how we do it? We can simply say val, we can say empty int array. So this empty int array is nothing but the, this val name, or we can say the variable name. Then we can simply say array. Now we have to pass the type of this array. So it will be basically type of int. And then what we can do is, we can basically specify the size, and the size will be of 10. And then we have to tell that what the elements will be. So you'll be saying that all the elements will be 0 for now, right? So now we are basically having this empty int array. Now let us see how we can basically print all of this, right? So let us try to print this empty int array for now. We can simply say print ln, okay? And after this, we can simply say empty int array dot, we can simply say join to string. Now this join to string, this is basically a formatter which we basically use. So you will be learning what it will be doing basically. So now you can see, right? So we got all the elements, which were basically 10 elements, because we specify the size of this entire array to be of 10, and we initialize that we want all the elements to be 0. So now we are basically having all the elements 0, right? Let us try to print the same thing for this numbers. So we can simply say print ln, and then we can basically say numbers, then we can say join to string. And if we do so, and if we try to rerun this, we'll be getting all these values 1, 2, 3, 4, 5, right? Now there are more ways to print these values. We can also say print ln, okay, and then we can say numbers, then we can say content to string. Now if we do so, we'll be not getting this format, but we'll be getting it like this, right? So we can still see the elements, right? However, there are more ways to access each of this element. We can also use a for loop. So we can simply say for, and in this for, we can say I in numbers, and after this, we can basically have this print ln, and then we can basically print the value of I with a comma and a space, okay? Now if we run this, we'll be getting all the elements which are 1, 2, 3, 4, 5, right? So we can basically have just a print statement over here, and we can still see that 1, 2, 3, 4, 5. So this is how you basically access the elements. And let us move on, and let us see how we can update a value, okay? So let us see that. So what we want to do over here is that, let us try to update a single value, okay? A value at a particular index. For now, I will be having a println over here, because I will be requiring a space. After this, what we can do is, let us suppose we want to make the first number, which was basically 1 to 10, okay? So we can simply say number 0 equals 10. Now what I am doing is, I am basically accessing, the 0th index of this numbers, and I am updating this with a value of 10. Now if we directly print the value, so let us say we say print ln, and we say numbers, and then we can basically say join to string. And if we do so, we'll be getting that updated, array, which is basically having 10th at its index 0, right? So we can directly update it like this. However, we can also do a few more things. We can directly say numbers 1 equals 20. By this, we can update the value at 1th index, and it will be now 20. Okay, so this is basically how, we update the values, okay? Now let us see how we can insert a value in between. Let us suppose we have this array, right? 10, 20, 3, 4, 5. And I want another value after this 20, I want a 30, but I still want that this remaining value should be present there. Now, I want to tell you something, okay? That is that, when you define or declare an array, its size is fixed, okay? So we cannot increase the size after declaring an array. So we cannot increase the size of an array which has already been declared, okay? So while declaring this numbers array, we specified 5 elements. Hence, the inference will by default consider this numbers array to be of size 5. Now we cannot insert a value at 6th position. The reason is that 6th position doesn't even exist. So we'll basically getting an out of bound error, right? So now let us try to understand the thing. So what we want to do is we want to basically insert 30 over here, which will basically increase the total length to 6, which is not possible, right? So what we'll be doing is we'll be basically creating another array and then we'll be storing that value at that particular location. So let us have one thing. We say that we want to store the value at index 2, right? So 0, 1, 2, and the value which we'll be storing is nothing but it will be 30, right? So what we can do is we can say val new array, and in this new array we can basically say array, and this array will be also of type int, and then we can basically say that the size what we wanting is that we want a size which is basically just one more than that of the the previous array size. So what we are doing over here is that the size the size will basically help us to get the size of the numbers array. So the size of the numbers array will be 5, and then we are basically incrementing one value over here which will make the new array size to be of 6. Okay, now what we can do is we can have this. Okay, now after this what we'll be doing is that we'll have this circular close bracket over here. Now we can say I over here, and after this we can have simple if else condition. So we can say if the value or the index is less than the index which we are currently focusing, then do one simple thing, just take the value of the numbers. Okay, but let us suppose if I reaches the index value which we have specified, which is basically 2, then what I want to do is I want to insert the value, and after this we'll be having an else condition where we will be basically having the numbers I. Okay, that's it. Now it will be basically I minus 1, right? So it is done. Now let us try to print this new array. We can simply say print ln, and then we can basically say new array. Now after this we have to also pass that content to string. We can directly say that. Now if we run this, see, now we are basically having that 10, 20, 30, 3, 4, 5. So now let us understand what is happening over in this code. So we have basically initialized a new array with the size 1 greater than that of the numbers array size, right? Then what we are doing is that we are basically having simple if else condition. So what we are checking over here is that if the index of new array is less than that of the index which we are searching, which is basically 2, then basically have the same value from the numbers I. So for the first time the index will be 0. Now 0 is less than 2, hence the numbers 0 will be inserted to this new array. So at this 0 index we were having 10, hence it will be having this 10. Now what will be having? Now this I will be 1. Now 1 is less than 2. Again numbers I, hence the next element which is 20 will be copied to the new array. Okay, after this the I will become 2 and our index was also 2, hence this value will trigger which was 30, hence the third element of this new array will become 30. Okay, now after this none of this condition will be triggered, hence this else will be by default which will execute, which will basically do is that it will come over here, and for let us say I value 3, it will basically store the value of I minus 1 which was basically 3. Okay, and then 4, then 5, and finally we'll be having that new array which will basically have the this element at the center or the position where we want to insert it. Okay, now let us understand few more things. Let us see how we can also create different other arrays. So like we can also create array which is of double. We can say val, we can say my double array, we can say that, and then we can basically say array of, and then we can basically have the values like 1.0, 2.0, 3.0, 4.0, it will be 4.0, and then we can basically have 5.0. Now we can also print the values. We can directly say print ln, and let us have the values. So we can simply say my double array dot, we can say join to string. So we can say join to, we can directly come over here and then we can say join to string. Okay, and if we do so and we run this, we'll be getting the array of doubles, which is 1.0, 2.0, 3.0, 4.0, 5.0. Okay, now let us try to do few more things. Let us try to implement like few DSA algorithms like linear search, binary search. So let us do that. Okay, for this what I will be doing is I will be basically commenting this out. Okay, now let us try to implement linear search. Now you will be knowing about linear search, and even if you don't know, let me explain what linear search is. So in linear search, we basically compare our key or the element which we want to search with all the elements of the array till we find the element in the array. Okay, so let us consider a simple array over here. So for this what we can say is, we can simply say val my array. Okay, and in this array we can simply say array of, and let us give few values like 1, 2, 3, 4, 5, 6. Okay, so we are basically having 6 elements. Now what I can do is I can have a for loop, and I will be saying I in, and I am doing it because I want to show the index also where the element is present. So I can say my array dot indices. Okay, now what I will be doing is I will be checking if my array I equals key. So I will be also requiring a key. We can simply say val key equals 5. Let us suppose we want to search 5 in this array. Now what it will do is that whenever this key is triggered, I will simply say that the element, or we can say element exists at index, or we can say index, and the index value will be basically I. Okay, so we can simply say $i. Okay, now what I will be doing is I will be also saying another boolean variable I can take, and I can simply say found, and let us make it false for now. And if the value is found, what I can do is I can say found equals true. And because we have already gotten the element, what I can do next is that I can break this loop because we don't want to go with the remaining ones. Now let us see what it is saying. Okay, so we have to make it var. Perfect. Now here we can simply say if not found. So if the element doesn't exist, we can simply say print ln. We can say element is not present in the in the array. Okay, now if we run this, because the element is present. Okay, so because the element was present and it was basically present at the index 4, let us see. So 0, 1, 2, 3, 4, hence we are getting that value at index 4, hence our code was right. Let us try to say that our key is 10, which is currently not present. Then we should get this element is not present in the array, and we are getting that element is not present in the array. Okay, so this is how basically linear search algorithm works. Let us also try to implement binary search. Now binary search is basically a very simple DS algorithm. Now how binary search works, it basically have a sorted array, and we try to find out an element in the sorted array. So for that, what we do is that we find out the mid of this sorted array, and let us suppose we find out the mid and the element, at the mid, and the element which we are searching is a match, then we can directly say that the element is present. If not, we'll be checking that the element which we are basically wanting to search, is it greater or is it smaller? So let us say if it is smaller, then we'll be, moving our end variable to mid -1, while if it is greater, then we'll be moving our start variable to mid +1. However, if you want to learn more about binary search, linear search, I have also added them in the documentation. You can go into the documentation to understand the concept much briefly. For now, what I'll be doing is I'll be also commenting out this again. Okay, so let us comment this out also again. And the next thing will be, let us cover the binary search. Okay, so we'll be covering the binary search algorithm, and it is very simple. Don't worry about that. Now we will be requiring an array, so we can say my array, and let us say it is basically an array of numbers like 1 2 3 4 5 6. Okay, now what we will be doing is that we'll be saying that we have a var which is start, which is basically 0, and then we'll be having another variable which is end, which will basically my array dot size -1. So it will be basically, the last element. Okay, now we'll be having just the circular brackets for much clear code understanding. Now we can simply say, we can have a var, or we can say val, and we can say found equals false for now. Okay, so it will basically help us to break the loop at any time if we find out, the element is present. Okay, now we can simply say while start is less than equals end, and then over here what we can do is, so it is basically saying something, let us see. So value of s is always 0, so no problem. For now we'll be modifying it, so we can simply say val, and we can say mid equals start plus end divide by 2. Now the next thing will be that, we come down, and then we can say if key equals this array, so my array mid, then we can simply say that the element was found. Let us have a key, so we can say key equals 5, let us suppose for now. And if this element found, then we can simply say print element exists at location, it will be basically mid. Okay, and then what we can do is we can make this, this found to be true, and then we can basically say break. Okay, so let us see what it is saying. Okay, so we have to make it var again because we are changing the state. Okay, now let us have the else. Now in else we will be basically checking if, if this key is less than that of my array mid. Okay, so if the element, the element which we are searching is less than that of the mid, that means the element is present in the left portion of the array, right? So for this, what we have to do is we have to change our end value. We can simply say end equals mid -1. Okay, and in else, that means the array is present on the right side. We can simply say start equals mid +1. Okay, and everything is done. We have to also have another if. We can simply say if not found, then we can say print ln. We can say simply that element doesn't exist. Okay, so we are done with our binary search algorithm. Let us try to run this code now. Because 5 is present, it should give us the location. Let us suppose we give something which is not present like 10, then it shouldn't give us, see, element doesn't exist. So this is how binary search basically work. Now see, there are various algorithms which can be, which we can basically implement on arrays or collection. So for now, I have tried to show you how linear search and binary search works. I'll be also attaching few questions in the description. You can try to solve them, and if you will be able to solve them, then it is sure that you have gotten the concept or grasped the concept of arrays. Now in the next video, we'll be covering sets, map, list, array list. With this, we'll be also covering more fundamentals in Kotlin, so you can master all of the basics to advanced concept in Kotlin. Till then, subscribe to the channel, hit the bell icon so you don't miss any upcoming video from us. This is Coding Up, signing off for this video. We'll be meeting soon.